Yo! Here we go. Theoretical probability of simple events. So this is going to be very similar to 12.1 because we've already talked about probability quite a bit. So in module 12, we talked a lot about probability at first, and then we went into experimental probability. So what happens when we conduct experiments to figure out how many times something's likely to happen. Now we're going to get into theoretical probability. So this is the probability something's going to happen without ever conducting an experiment. This is just what should the probability be in general. So here's your definition of theoretical probability. It is very, very similar to the definition of regular probability. So your formula for theoretical probability is also very similar to your formula for just probability that we've already talked about. So today's not really a lot of new things. It's going to be a lot of the same of what we've already been working on. So let's get to it. So a bag contains 6 red marbles and 12 blue marbles. You select one marble at random from the bag. What is the probability that you select a red marble? Write your answer in simplest form. So the probability of an event happening, So the probability of an event happening, the probability of something happening is equal to a fraction where the numerator is the number of ways that specific event can occur. So if I'm looking for the probability of red, P parenthesis red means probability of red. If I'm looking for P, the probability of red, well, I need to figure out two things. I need to figure out what are the total number of equally likely outcomes. So how many marbles are there total? Well, we have 6 red, 12 blue. So that gives me a total of 18 marbles total. Now, how many red marbles do I have? And that goes in the top, 6. So it's just 6 over 18. So 6 over 18, I would then want to simplify that. And this is the part where some people are still struggling, so we're looking for common factors between 6 and 18. What number can I divide these both by? And I can divide them both by a 3. I also could divide them both by a 2. I could divide them both by a 3. You know what? I could even divide them both by a 6. So let's just do 6 so we don't have to do this one time. 6 divided by 6 is 1. 18 divided by 6 is 3. So the probability of pulling a red marble is 1/3. So you have a 1/3 chance, 1 out of 3 chance to pull a red marble. And that's it. You roll a number cube 1 time. So it's the standard 6-sided dice with numbers 1, 2, 3, 4, 5, 6. What is the probability that you roll a 3 or a 4? Write your answer in simplest form. So here's the probability of rolling a 3 or a 4. Well, whenever we roll a dice, I want to go, I know the bottom here is I'm looking at 3 or 4 is my numerator. And my total possible outcomes is my denominator. Well, how many total possible outcomes are there when you roll a dice? There's 6. Okay, whenever I roll a dice, I can roll a 1, a 2, a 3, a 4, a 5, or a 6. So the probability of rolling a 3 or 4 is going to be something over 6 because there's 6 possible outcomes when I roll a dice once. Well, how many 3s or 4s are there on a dice? Well, there's 1 3 and 1 4, so there's a total of 2 opportunities to roll a 3 or a 4. So it's just 2 over 6, which simplifies to 1/3. Okay. This one, I mean, it's the same idea. It's just got a few more steps to it. Try doing it on your own. See if you can fill it out on your own without even me going through it. See how you do in this one? Try doing both of these on your own. So pause it, try them out, see how you do. Please actually pause it, and then we'll check back in. Okay, so at a school fair, you have a choice of randomly picking a ball from basket A or basket B. So you have 2 baskets that you get to choose from at the fair. You can win a digital book reader if you pick a red ball. So your goal is to pick a red ball, and then you win a digital book reader. Well, basket A has 5 green balls, 3 red, and 8 yellow. basket B, I'll do this one in orange, has 7 green, 4 red, and 9 yellow. We want to figure out what the probability, and if one of them has a better probability to pull out, one of them gives you a better chance to win that digital e-reader, okay? Or that digital book reader. So first, we got to figure out for basket A, what are the total possible outcomes? So for basket A, we'll go back to purple here. Basket A, there's 5, 3, and 8. So 5 plus 3 is 8, plus 8. There are 16 possible outcomes for basket A. Let me do that in purple. Thought I selected purple, but I didn't. 16. And the amount of red balls there are 3. So my probability is 3 out of 16 to select the red ball. For basket B, there are a total of 7 plus 4 is 11, plus 9, there are 20 balls. And 4 red ones. So the probability of winning that book is 4 out of 20, which is 1 out of 5. So now I have my two probabilities. I have 3 out of 16 and I have 1 out of 5. So I want to know which one gives me the better odds. Which baskets does I choose if I want a better chance of winning? Well, unfortunately, it's hard to compare these right now because one's 3 out of 16 and one's 1 out of 5. So they don't have like denominators, so it's really hard to see which one's better. But I know there's a really easy way to know the exact probability for each one where they're not a fraction, and that's if I just use a calculator and change. This is when it's really nice to have percentages. So I can do 3 divided by 16. And that gives me a 0.1875, but if I move my decimal over twice, that's 18.75% chance. Well, 1 out of 5, I just know that one is 20%, because 1 divided by 5 is 0.2. So you have a slightly better chance because your probability is better. You have a 20% chance to pull a red ball out of the basket B. You have a 18.75% chance to pull a red ball out of A. So you have a little bit better chance out of basket B. Not much, but it's still a better chance. So if you really wanted to win, you would be smart to choose basket B. Find the probability of the event. You spin the spinner shown, the spinner lands on yellow. So what is the probability of landing on yellow? Well, there's 1, 2, 3, 4, 5, 6 sections total. 2 yellow, so 2 out of 6. So you have a 1/3 chance of landing on yellow. Okay, guys, that's it. Okay, there's nothing else here for things to remember. I mean, we can put total possible outcomes in the denominator again, but I feel like we've been saying that a ton. So instead, for things to remember, draw a house. And I'm going to have a little chimney on my house. We'll have 1 window. Actually, let's do 2 windows. There's my awesome house. Here, and I'll even have a tree. Okay, and some grass. There we go. So draw a house for things to remember because we've written down this formula 17 times. All right, get your independent practice done. If you have any questions, please let me know. Rudius out.